Okay, so in this video we're going to go over specifically the relay. And the reason why I want to go over that is because I found a lot of students get confused over this particular part by the simple fact that it's got all these different connectors on it. And they don't know what goes where and why. And so I thought we'd just take a quick minute to go over this. So like I said before, your relay is a lot like your light switch. Your 24 volts or your control voltage acts as your on-off switch. And then you're simply breaking one leg of power, and that power is either being parked right here or it's being allowed to pass through and control your load, in this case your furnace. So how do we know what goes where? Well, your control voltage goes down here at the bottom, but why do we put it there? Well, usually you can determine where your control voltage goes by the fact that you can see solder marks on where these stake-on connections are. So you can't see it on camera, but I can, and there's solder marks down here, which indicate to me that's where my 24 volts goes. Now you can also tell by the fact that this control voltage side is slightly lower than the rest of this. But another way you can figure it out is because if you look here on the actual part itself, and again, you can't see this on camera, but I can, there's diagrams on this black plastic. And those diagrams are showing you what's going to happen with your voltage depending on where you place your outgoing stake on. Now, the incoming power to your relay will always be on this side of the relay. Now you can control up to 2 different devices, but your incoming power will always be here or here. So I could switch this incoming voltage to this side if I wanted to. I could have it on both. I can have it on one. And then your outgoing voltage will either be in one of these middle prongs here, or one of these far prongs here on the outside of the relay. And that all depends on how you want that power to work. And what you can't see is that on your middle prongs, you have this normally closed switch. This is the markings for normally closed. Think of this as 2 contactors that come together to create a pathway for electricity to pass through this side to this side. When these close, the electricity flows through. When they're open, electricity cannot flow through. It sits here and can't go here. And that's what's happening here. You have your electricity incoming here. It's being parked on this side, but until this closes, it cannot pass through this to this side. So when you're on the outside stake here, that is a normally open position, which means until you supply your control voltage, your 24 volts, power will not pass from this side to this side. Now if I were to take this outgoing side and move it here, now that means that this is a normally closed switch. So if I don't have power supplied, I'm still going to have power going from here to control my furnace. Now when 24 volts is applied, this opens and the power stops from here to here, and this turns off. Now I'll give you an example of that right now. So we're gonna make a heating call, and when we do that, as you can see right now, I have the power on, the thermostat is set to off, and my furnace is not working. So that means right now I have no 24 volts here, and my power that I've got, my hot leg coming off of this bus bar coming here, my power is just sitting there, and it's waiting to be passed over here to this side so that the furnace can start. So as soon as I make that heating call, that power will pass through, this bulb will light up. There you go. Now, if I were to take this wire off and move it to the normally closed position, even though I don't have my thermostat switched to heat and it's in the off position, my furnace will turn on. There you go. And when I turn my power on to heat, or my thermostat to heat, and my 24 volts comes in, this will now shut off. So that's really important to know. And as long as you can commit it to memory, I mean, you can always look at the contactor itself and it'll tell you what's doing what stake controls what, whether it's normally closed or normally open. But if you can remember, my incoming power always comes here, normally closed, normally open, you'll be good. And of course your 24 volts goes here, and how do we know that? Well, it's stepped down lower. The stake-ons are stepped down lower, and we've got solder on the points, indicating that it's our 24 volts or our control voltage side. So hopefully that helps you make a little more sense of the relay, and not have so much confusion when it comes to what wires go where and why.